My name is Alexis. I work for a company called Zopa as a React Native developer. Big news today. We just submitted our app to the App Store. Hopefully we get approved. Zopa is a fintech company which focuses on peer-to-peer lending. So we've been working on this application for about a year now. Mostly we did some prototyping, MVPs. We changed different features inside the application based on legal requirements or different, different reason, backend technical reason. Finally the app is out in a few days. We also submitted it for Android, and we are planning to publish it on both platforms at the same time. So the application is basically an application to see your loans, and you can also get your credit score for free on the application. And in the future, we are planning to add a few more features as the company is becoming a bank. So we'll have a few interesting bank projects coming inside the application as well. So today I'm going to talk about how to modularize your React Native application. I'm going to go through the challenges that we face as building large and scalable applications. This applies for any kind of JavaScript applications, can be any framework, but I'm going to focus on React Native as well. What actually is a modular structure, and how to build React Native application out of modules. And then I will give a few tools to help you build an application out of modules. So the application we built at Zopa is using those concepts. The company is divided by squads and tribes. I don't know if you've ever heard of that. By raised hand, how many of you? Yeah. It's started mostly with a company with Spotify, where they had some problems. And they were growing very fast, and they wanted to find a solution how to build faster, how to release faster. And I'm not sure they came up, but and they use this concept of tribes and squads, which basically a tribe focuses on a project, or for example, in my company, a squad can focus on loans, and another squad will focus on investment. And the tribe is composed by squads, which focuses on different sections of the project. So first, how do we deliver maintainable and scalable JavaScript applications? Working at scale, it can be difficult. I used to work for a bank for about 2 years. I used to live in Canada, and I used to work for one of the biggest banks in Canada. And I was working as a JavaScript developer, and I've been picked to be part of rebuilding the entire redesign of the website. So the website was built with Ember.js. It wasn't my decision. It's too bad for them. It took about 2 years to rebuild everything, and it was a big mess. So we built a huge monolith, basically in JavaScript. We only had a single bundle.js, which was about 2 meg, minimized. We had hundreds of files and dependencies going in all directions. There were no specific rules. The technical lead was just good at talking and wasn't good at building things. But the management, they were trusting him. So basically what happened. So it was a butchery, to be honest. And so I wasn't leading anything. I didn't have any word to say, unfortunately. But I decided to focus and to spend some time to think about how we can avoid these kind of problems by building front-end application in a more modular way. So first, what kind of challenges we face building large-scale applications? So you start with some code. It's very simple at the beginning. You organize your folder like most people. Create a container folder, a Redux folder, actions folder, reducers folder, anything you want. And then you continue and you add more files to those folders. And you have a pretty flat, how do you say, structure of your dependencies. And so as your code grows, you start to import files from different directions. And mostly it slowly starts to get difficult to understand the relationship between your different files. And you happen to spend more time figuring out what are the relationship between the file rather than actually understanding the code and actually writing code as well. So relationships start to get in all directions because you don't have any rules. Maybe you have rules like you cannot import a reducer from a different place than inside another reducer or inside the store, or you cannot import actions from, for example, presentational components. You can have these kind of rules, but at the end you might also import files in all directions, and you end up with something like this. So the code becomes unreadable, it's too difficult to make changes. You happen to have over-engineered everything because you didn't think about how to modularize your application in smaller pieces. On the backend world today, we tend to create microservices, and there is a good reason why. Before, we were using mostly monolith and huge APIs or huge front-end applications, and now we focus mostly on microservices. So on the front end, you can also apply those rules by simply, actually I'm going through the rules after. So yeah, like I was saying, no coding standards, no structures. Sometimes you don't even have any code reviews, depends on the company you work for. And you have too many relationships. So the main reason why this happens is ignorance and inexperience as well from developers. They are not aware what's going on. They spend a lot of time trying to figure out things. When they work, they just dump the code and it works, so it's fine. And we build on top of it, and it gets too complicated. I worked in many companies with this kind of code. Mostly when you work, for example, with offshore companies like in India or Vietnam or anywhere in Asia, you might have a huge monolith of JavaScript, and it's super complicated to understand because, I guess, of inexperience from the developers. So I spent some time over the past few years to think about how to make JavaScript application more maintainable and scalable, and to have an architecture where you can plug anything and remove anything without breaking an application, or without breaking too much the application, at least. So first, what's a modular structure? So like I said before, Spotify works as a tribe and squads. So my company as well, Zopa, we work as squad and tribes. So a tribe is a cross-functional. It's cross-functional, so it's for a single project. Has autonomous entities, so it means they have their own testers, designers, developers, backend, frontend, everyone they need to build a project. And it helps them to grow faster as they create new squads and new tribes to add new features or projects inside the application. In the world of JavaScript development, the same rules can apply. So a module can be anything. It's up to you to decide what is a module. A module encapsulates a set of functions and components that are related from each other. So for example, you can have a payment module, security module, emailing module, music library module, search module. It's anything you want. It's up to you to decide what's a module. So when you create a module, you need to make sure that module is completely independent from the rest of the application. You don't want too many relationships between your module and the other modules. So each module provides a public interface. It's like a node modules, pretty much. So it provides a public interface, and that's pretty much it. So you cannot access the store, or you cannot access anything that these modules does. You just have a public interface that you contact with an API, and you just call the functions that are provided to you. So basically, that's the Unix philosophy. Do one thing and do it well. It has a single, so each module has a single responsibility, but has only one reason to change. So you should not have a module that does more than one thing. So for example, security will only take care of everything related to security, so authentication of the user. So, but you won't have, the security module won't call anything related to the library, for example, of the search. It's really encapsulated with its own features. Another good thing about modules is A/B testing. You can easily remove a module and place another module instead for A/B testing, or for any other reason. So it can be because you want to create a version 2 of the module, and you want just to swap it. So as long as the API stays the same between your module, the previous module, and the new module, your application won't break because the API is the same. Make sure you have functional tests as well, but it's pretty easy to swap modules. So I just put together a few rules, set of a guideline how to build modules and what I mostly do. So I compose my module based on what they provide to the user. They contain everything they need, which means they contain assets. They contain Redux, actions, and reducers, anything. They also contains the code itself, components, navigators, which means you don't define your navigators in the base of the application. You define your navigation inside the module. They have unit tests. They have functional tests if you need to. It depends how you create functional tests. And this mostly is to avoid to have a base code where you dump everything inside. You don't want a base code with helpers and utils methods and things that you don't know where to put, so you put them in the base code. You don't want a global style because it's too complicated. After, you might break something from a different part of the application. And you want also to avoid central configuration. So if you have a configuration that only relates to a specific module, like the search, you want this configuration to go inside the search module as well. So you don't want the configuration that for your entire application. Another rule I try to apply is to have as much as possible a flat structure when you create your folders. This reason, because it's easier to access a folder or a file within a flat structure, and it helps to reuse your modules and components. Next, when a module becomes too big, I tend to break them down into 2 modules because it gets too complicated. It means it has too many things inside, and there are a lot of reasons why you might want to break it down in smaller modules. just because after it gets too many nested folders, gets too many components that are not related to the modules, and it's quite easy actually to move a module around. So especially with React, you can import files pretty easily, especially if you use a module pattern. And another one is forbidden dependencies. This one is quite important. So if you have your home screen, for example, you don't want to import anything inside the home screen. Maybe you just import the search module inside the home screen, but you are not going to import the search library to access the API. For example, if you have a search library, you want to import the search module, and that search module will give you access to the search API if you need to access it. But at least you don't have access to everything from the search API because you might break something, you might break the search module at some point. The component pattern is great to use, which means you have all your DOM, your styles, and your JavaScript within the component. You also have your tests and assets, if possible, if you don't reuse them. So I tend to use that quite a lot. And because it's easier to refactor, it's easier to delete. You don't separate components based on what they are. You separate them based on what they do. So you don't have a folder with containers and a folder with presentational components. You have a folder that you call search, and inside this folder you have your container and your presentational. Actually, talking about container and presentational, I started slowly not to do any container and presentational anymore. What I prefer to do is to create smaller components with a smaller thing to do. Dan Abramov, which I'm sure every one of you knows, said a few years ago, actually, it's 2016, people are reading way too much into presentational and container components divide, almost regretting I wrote that. And most people use that actually today. So the component pattern, you will see it like you have a profile folder, and inside you have, for example, a summary of the profile, which is connected to the Redux store if you need to, but you also have the styles and everything, the presentational part. But the component is quite small, so it's easy to read, it's easy to understand what it does. Instead of having a profile component, which contains every presentational pieces, and a profile container which contains all the logic, I create a profile folder, and inside I have a small summary file, a small details, one settings, and Redux if I need Redux, which will contain a few action creator to get the user profile, for example. So, all right. So I put together a quick demo how to apply those rules on a React Native application. So actually, I don't need those slides. So what I'm going to present is, so I created a quick demo where you can authenticate a user using your fingerprint scanner. So that modules provides a public API with a component called authenticate, and two methods, actually three methods, two to get and set the sensor preference, and one to know if the sensor is available or not. All right, let's go. I generated an application with React Native in it. And I created a package folder which contains 4 modules. One is the home screen, one is the login screen, one is security, and another one is UI. So what I've decided to do is, so inside the app.js here, what I do is I just define the stack navigator with login and home. That's all it does, which means if you have a navigation with inside home that goes somewhere else, home decides the navigation. And if you have a navigation inside login, for forget password or for signing up. Login, we have its own navigation as well. And just when I start the application, I just want to go on the login screen. That's all I want. Oops. So packages. OK, so inside packages, I have the login screen. Let me open this in VS Code. OK. So I have the login screen. What the login screen does is has two buttons. One to navigate to the home screen, and one to request authentication, and also check if there is. Actually, it also injects the authentication component. Basically, this component, what it does, it shows the fingerprint scanner. So this component comes from the security package here, and the button components come from the UI package here. So let me show you how this looks like. So when you press here, basically it navigates to home. Home gives me an information to tell me if the sensor is available or not. So I haven't enabled it yet, so that's why it says it's enablable. And if I press here, I just get an error from the sensor. Actually, the security package that tells me, OK, you have a problem and you cannot use the sensor. So I'm going to enable Touch ID right now, just refreshing. If I navigate to home, so it tells me now that the sensor is not enabled. So if I press here, wait. Interesting. OK, there is a bug. It should tell me that exactly that it's not enabled. I put this name quickly yesterday. So and if I enable the sensor now, I can use my fingerprint. It tells me I successfully authenticated and navigates to the home screen. So all the logic behind the sensor and behind the security, everything comes from the security package. It doesn't come from the home screen, and it doesn't come from the login screen. Everything comes from the security, and that means you can also use the security package to make a payment or to authorize something important inside your application. Or even if you need to enable the fingerprint inside the setting page and you want to request to display the fingerprint scanner, you can just call the security package. So the localhost is pretty straightforward component. It actually doesn't render anything because for iOS it doesn't require anything to be rendered. I didn't build the version for Android because for this demo I didn't need it, but for Android you will need to build your own pop-up to display the fingerprint sensor. And it has a bunch of methods, which is actually, it's more like a wrapper around the React Native fingerprint scanner library that I use. But it's a wrapper, so I can decide, get sensor preference. So what it does, it basically reads the async storage of the device and returns the status of the sensor from the async storage. Sets sensor preference just reads the async storage, and is sensor available, just use the fingerprint scanner method. And I created an enable sensor method that is used by the localhost component, and is just a wrapper around fingerprint scanner as well. If you want to throw an error if the sensor is disabled, and you want to trigger on success and on failed and release the sensor as well. Especially you need to release the sensor for Android every single time it fails, otherwise you cannot reuse it again. So those methods can be publicly accessible, but if you want, for security reason, I might decide not to provide access to the enable sensor from an external point of view outside the package, and just to give access to the local host component, which means every single time I want to use a fingerprint scanner, I have to use the component. And it has everything it requires to work on its own. That's pretty much it. So it has its own package JSON, which requires React Native fingerprint scanner and has peer dependencies on React and React Native. So yeah, like I said, the security module can be used by payments, settings, login, any modules that you want. And if you make a change to the security modules, it won't break anything if the API changes. So if, for example, you want to swap and replace the fingerprint scanner by a PIN number, by PIN, you can do that as long as localhost component still exists. And instead of bringing the fingerprint scanner, it will bring the PIN to enter inside the phone. And the entire application still works exactly the same way. So that's pretty cool. Along the way, there are two tools that I found very useful to use when you work with modules. The first one is Learner, especially if you work in a large team. So Learner is a tool which helps you create multi-package repositories. So you might want to have a single repository for each of your module. But at some point, you will create dependencies between all your modules, and it will get difficult for you to create a pull request, to make your change, to get it approved by someone else, to merge it, to publish it to NPM, and to continue like that for all your packages. And if you have like 15, 20, even more packages, it might get difficult to have everything and to get everything working together. So what Learner does, it helps you manage a monorepo, turns your code base into packages, and each package can be published to NPM if you like. So if you create a UI library for your React Native application, you can just publish your UI library to share it with the community, while the rest of your code base stays the same, and you can use all your components. So it creates symlinks between packages, which means, like you saw in my code, I was importing from RNL application because it created symlinks in my node modules folder where I can import any node modules that are defined inside the packages. So that's quite neat. And the good thing about multi-package repository is you can have a single configuration file for your entire project or all your projects if you decide to have more than one mobile application within your multi-package repository, which means you have a single ESLint configuration, a single unit test configuration. Everything is shared between all your packages, and it's pretty neat. An engineer from Facebook said jungling between multi-modules project over multiple repos is like trying to teach a newborn baby how to ride a bike. And it's pretty true, because we've tried it in my company to have multiple repos for multiple packages. And at the end, it was taking more time for us to get our pull request approved and merged and published to an Artifactory, and to get that modules available, and it was super difficult we were spending more time trying to release packages rather than using them. And the second tool that is quite nice to use is GitHub Code Owners. When you work in a large code base, if you have many developers, let's say 10, 15 developers, you might want to assign some developers to a certain package and some other developers to another one. You want to separate them based on the team. So if one team works on the security modules and another team works on the search module, you can assign code owners to those packages, and they will be required to approve your pull request in order to merge them. This avoids conflicts between the different teams. And sometimes it breaks something because the pull request got merged without the approval of someone who has more knowledge about the package. That's pretty much it for me. Thank you very much for your time. I am on Twitter and Medium with this handlebar if you want to follow me. And if you have any questions about the talk, speak up now or I will be available after. That's pretty much it. Thank you.